Today we are starting Unit 4, and we're going to be simplifying expressions using exponent properties. So we're going to briefly review properties of exponents and then do a few examples. So if you have a product of two terms, both with the same base, and that's crucial. They have to both have the same base. So both x's, both y's, whatever, and they have powers. You're multiplying them together. What do you do with those powers? Well, you add those together. So this would be x to the n plus m, like that. And of course you could reverse those. Addition is commutative, so you can reverse those and make it x to the m plus n. What if you have a base raised to a power, and that is raised to a power? What do you do with the powers then? I call this a power to a power. What is a power to a power? Well, you keep the same base, and you multiply those powers together. N times m. And of course, since multiplication is commutative, you could reverse that and make it m times n. Which means that if you wanted to, you could write this as x to the m all to the n power. We use that sometimes when you have something like, let's say 25 to the 3/2 power. We use that property. We take the square root first and then cube. So we're doing the square root first and then cubing it. It just makes sense to do it that way. So that is a good property that we use often. All right, x to the negative 1. How could we write x to the negative 1? We could write that as 1 over x. And that is the same thing as, if we have x to the negative 2, what could we write that as? We could write that as 1 over x squared. What if we had x to the negative 1/2? How could we write that? We could write that as 1 over x to the positive 1/2, which is the square root of x. Okay? All right, x to the 0. X is representing a number. A number to the 0 power is always 1. Okay? All right, what if we are dividing? I probably should have put this property right after multiplying. What if we're dividing to same bases? Well, you could write that as, what I do is I look which base is larger. Is n or m larger? That's going to determine where I'm going to put my value, my expression. So this can be written as x to the n minus m, or if m is bigger than n, I would write that as 1 over x to the m minus n. So if you have x cubed over x to the 9th, since 9 is bigger than 3, I would write that as 1 over x to the 6th. But if I had it the other way around, I would write that just as x to the 6th. Okay, let's take a look at some examples. All right, what can we do to, quote, simplify this? Well, these two can be combined, and those will become x to the, we add those two powers, x to the 10, minus x squared. Can anything further be done with that? No, those are not like terms. They're separated by a minus. We leave it just like that. Okay? Over here, we have some things, some fractions being multiplied together. So a couple of different ways I could do this. I think to begin with, I'm going to multiply my numerators together and my denominators together. I can see a few different ways to do this, but that's what I'm going to do this time. X to the 3rd times x to the 1st will be x to the 4th. The y to the 5th is going to hang out for a second. And then on the bottom, we have the x to the 8th, and we have y to the 7th times y. That's y to the 1st. So we add those powers, and we get y to the 8th. And now we can reduce. And the 8 is bigger than the 4, so that's going to leave an x to the 4th on the bottom, and 8 is bigger than 5, that's going to be a y cubed on the bottom. Nothing left on top but a 1. 1 over x to the 4th times y cubed. Okay, number 3. All right, we have a fraction being raised to a power, and I'm going to what could we do with this? We could write this as x cubed to the 7th power, divided by y to the 4th to the 7th power, and that is x to the 21st over y to the 28th. And no, of course, you do not have to write that middle step. That's just for the sake of your notes. That's what I'm doing. Okay, number 4 here. We have a negative power. Okay, a couple different ways I can consider this. How would I do this? Today I'm going to just apply the x cubed to the negative 7 power, and that's going to make it a negative 21, almost wrote 28, 21, and then over y to the 4 times negative 7 is negative 28, and this is going to make it, since this is just a single fraction, this is going to bring the y to the 28th to the top and make it positive, and the x to the 21st to the bottom, and make that power positive as well. Okay. Number 5. It's kind of messy. What should I do? Should I reduce then do this power? Should I do the power then reduce? Either way is fine. Doesn't really matter. Again, we do it all the time. It doesn't matter which you do first. Do you cube first and then square root? Do you square root then cube? Doesn't matter which one you do first here. I think today I'm going to simplify and then raise to the power. So let's take care of our x's. I've got x to the 4th over x to the 5th. That's going to leave an x to the 1st on the bottom. This y to the 0 is just 1, so that's just a 1. That's not going to affect anything, right? I'm left with that y to the negative 2 on top that I'm going to bring down to the bottom and make it y squared. And now for my z's, I have z to the 7th and I have z to the negative 6th. The z to the negative 6th is going to go up to the top where it will be a positive power, and I'm going to add it to the z to the 7th, and that will make it z to the 13. Another way you can think of that is 7 minus a negative 6 is positive 13. And now I will apply the negative. What's going to happen with when we apply the negative? It's going to flip our fraction. So it'll be xy squared divided by z to the 13th, all to the positive 2. And now lastly, I'm going to apply that positive 2 power, raise each thing to that power. So I'll have x squared, y to the 4, divided by z to the 13 times 2, 26. All right, what if we have a fractional power here? Well, the first thing I see is something to the 0 power. Something to the 0 power, I'm going to get rid of that. It's just a 1. Okay. And then what do I see next to do? I think next to do, I'm going to take, well, I think I'm actually going to move these negative powered terms to the top. I think I'm going to do that this time. So, okay, the 32 is going to stay a 32. I'm moving this x to the negative 2 to the top. It'll be a positive power then. So x to the 8th times x squared is x to the 10th. Okay, and the y to the 15th, there's no y on the bottom. Z to the negative 5, I'll bring it to the top and make it a z to the positive 5. And the only thing left on the bottom is 243. And now I'm going to raise everything to the 2/5 power. So here's what I'm doing. The 32, I'm going to raise it to the 2/5 power. That is the 5th root of 32 squared. The 5th root of 32 is 2. 2 squared is 4. The 243. The 5th root of 243 is 3, and then 3 squared is 9. Now for my variables. x to the 10th. I'm multiplying 10 times 2/5. If you need to come off to the side, 10 times 2/5. 5 goes into 10 2 times, leaving a 1 on the bottom, and that will be 4. So x to the 10th to the 2/5 is x to the 4th. Let's do it with the y term. 15 times 2 over 5. 5 goes into 15 3 times. 3 times 2 is 6. This is y to the 6th. 5 times 2/5. 5 goes into 5 one time, leaving a 2, so z to the 2nd power. Those can get messy, and we just have to take our time, do it right. Okay, these last few are not as messy, but they are a little different. What makes these different is the plus or the minus inside these terms. When I see x to the negative 1 with a plus sitting right next to it, you cannot move this to the bottom. You have to write that as 1 over x right there plus 2 over x plus 3. Do not move that x to the bottom yet. Okay? Now what I'm going to do is I'm going to multiply top and bottom by that x. And I'm going to get x times 1 over x is 1 plus 2x divided by, and here we have a choice. You can distribute that x, or you can leave it in factored form. It does not matter which. You can write it like that, or you could write it as this. If it's multiple choice, you go get the one that is correct. Otherwise, leave it however you like. So for this one, there's a minus, so we cannot just bring these guys to the bottom. We have to write it as 1 over x minus 1 over y, all divided by xy. And now I'm going to multiply top and bottom by xy to get rid of the complex fraction. And I have 1 over x times xy is y, minus 1 over y times xy is x, all divided by x squared, y squared. Let's do one more. Okay, so this will be 1 over x squared plus 1 over y cubed divided by 1 over x cubed plus 1 over y to the 4th. All right, what are we going to multiply top and bottom by this time to get rid of our denominators, all of our little denominators? I'm going to multiply it by x cubed because that is the bigger one, and I'm going to multiply by y to the 4th because this one is the larger one. Okay, so 1 over x squared times x cubed leaves me an x. 1 over y cubed times x cubed y to the 4th, that does leave me an x, y to the 4th, goodness, okay. And then the y cubed was going to reduce with the y to the 4th, leaving me a y, but I still have that x cubed, so x cubed y, divided by, here the x cubed will reduce out, leaving a y to the 4th. The y to the 4th will reduce out, leaving an x cubed. So that is it. Okay, cannot reduce that further. So a brief review of properties of exponents.